All right, this is the last of our rock labs. This rock involves the identification of metamorphic rocks. So metamorphic rocks are those rocks that changed from one rock into another. They are subject to heat and pressure, unlike in which they were originally formed. So they've been transformed, metamorphosed into a new rock. And so when it comes to metamorphic rocks, we have 11 samples out today. These are the simplest rocks to identify. One thing about metamorphic rocks is all the samples that we're going to look at today all have a parent rock. So there's two types of texture that we look at in a metamorphic rock. One is foliated and the other is non. So what's the difference between a foliated rock and a non-foliated rock? It's simply foliated rocks have a layering to them. There's a distinct layering to these rocks. Banding, layers. This is a characteristic that was brought on by their sedimentary parents. And then the non-foliated rocks have no layering to them. They're just mostly massive. And some of them are crystalline. So we look at basically foliated, non-foliated, and then we look at what's in the rock. So basically there are two charts, and I combined those two charts into this one chart here, and the black line separates the non-foliated rocks from the foliated rocks. And then this rock chart here is all the non-foliated rocks, and this rock is the foliated rocks, the rocks with layers. So again, we're going to take our lab worksheet. We're going to ask ourselves a question. So let's go over the example here. You're going to have either foliated or non-foliated. If you commit to foliation, you now have to tell what the degree of foliation is. Foliation type. So if that rock has a slatty foliation, then guess what? The rock's going to be a slate. So primarily, you're going to have most of the answers to this lab just by going through the textures. And then we're going to look at the mineral composition, what's in it, and then the parent rock. And then we'll name the rock. So foliation and non-foliated. So samples numbers 1, 2, 3, and 4 is what we refer to in lecture as the metamorphic grade. Low-grade metamorphism to high-grade metamorphism. Remember, metamorphic rocks can never melt, because if they melt, they become magma, and then they will then crystallize or come to the surface and form igneous rocks. So let's look at number 1. Number 1 can vary with respect to color. It can be red, black, green, tan. And so this rock here is definitely foliated. Why is it foliated? It has layers to it. So this is a layered rock. It has a very dull surface to it, very dull. So its foliation type is slatty. Slatty foliation. Mineral content. What's in this rock? Clay minerals. What's its parent rock? A shale. Moving on to number 2, increase in metamorphic grade. Unlike number 1, which is dull, no shine to it, this one has a little bit of a shine to it. So there's a little shine to this rock here. Just a slight shine. No visible minerals yet. So number 1 and 2 have the one thing in common is that none of them have really any visible minerals. So this is foliated. It has layers to it. Its foliation type is phyletic. Its composition, clay minerals. Mineral content, clay minerals. Its parent is a slate, or was a slate. Number 3, this rock now has visible minerals. It is foliated. It's got a flaking off of the minerals. The minerals kind of line themselves up. So number 3 is foliated also. Its degree of foliation is schistosity, or schistose. Its parent rock was a phyllite. What's the mineral composition here? The shiny stuff are micas. And if you look close enough, and this camera may not pick it up, but there's actually garnets in this rock. So garnets and micas are what we're going to put down for mineral content. The parent rock of this rock here, again, was a phyllite. And number 4, the highest metamorphic grade. You can definitely see a layering in this rock. Pink potassium feldspar with a black amphibole. So that's going to be the mineral composition of this rock. It's going to be K-spar and amphibole. It is a foliated rock, and the layer of foliation is gneissic. Its parent was a schist. Number 5, this is a black rock, and it contains 100% very fine grain amphibole minerals. So this is a foliated rock. It is foliated. It is the layering of the amphibole minerals lining up. So this rock is basically 99% amphibole. Its parent, believe it or not, is a phyllite. So the parent of this rock is a phyllite, and it contains amphiboles, and the name of this rock comes from the mineral content. So the mineral content of this rock is amphibole. Number 6, a nice green rock, definitely has foliation to it. So this is a foliated rock, and so is number 7, but it doesn't show the foliation. Ironically, as these 2 rocks came from the same locality, the same place, right along the San Andreas Fault. So both of these rocks are considered foliated, even though you can't see the foliation in this. So because it's not foliated, we just call it a stone. It's a green colored rock, and the last part of its name is stone. So 6 and 7 are both foliated. The degree of foliation is schistose. Same with number 5. The lining up of the amphibole minerals makes this a schistose foliation. So definitely is this one. This one we don't call it, we call it a stone. And it's based on this color. So what's in both the 6 and 7, why they're a green color? So the mineral content of both 6 and 7 is going to be chlorite. Their parents were phyllites. They're very similar. The difference is the degree of foliation between these 2 rocks. They both contain, in the mineral content, chlorite. Moving on to number 8. Number 8 can be a variety of colors. This rock is soft. It will not scratch glass. This rock also reacts to hydrochloric acid. This rock is non-foliated. So this is non-foliation. So the foliation type we just skip. Mineral content, since it reacts to acid, it contains calcite. So this rock contains calcite. So the mineral content of this rock is calcite. The parent of this rock is a limestone. The parent of this rock is a limestone. It is non-foliated. Number 9 can come in a variety of colors. Number 9 will scratch glass. It's non-folated, so you don't have to worry about the foliation type. Its mineral or content is quartz. Again, its parent was a sandstone. So the parent rock of this, a sandstone. Number 10, its parent was bituminous coal. This has been metamorphosed. The mineral content of this rock, carbon. A little bit more of a pure form of carbon. So number 10 is non-foliated. Its mineral content is carbon. Its parent was bituminous coal, the sedimentary version of coal. Last, we have number 11. Its parent was either a conglomerate or a breccia. So conglomerate or a breccia for number 11. Non-foliated. Although sometimes with the way the grains are foliated, people want to call these rocks foliated. And that is an often mistake that is made. They're really not foliated. So I'll just give you a heads up on this. So the parent was either a conglomerate or a breccia. The chemical composition or the mineral composition of this rock is basically rock fragments. Rock fragments and quartz. And definitely non-foliated. So that's metamorphic rocks. Pretty straightforward. Not a whole lot of metamorphic rocks. The metamorphic grade contains most of those. And all the rocks in the metamorphic grade originated as a shell. As that shell was baked, it became a new rock, a new metamorphic rock, and then that metamorphic rock, under more heat pressure, went to a higher grade of metamorphism, then to the third highest grade of metamorphism, and then last, this is the highest grade of metamorphism. After this, these rocks will melt and basically turn into magma, and once they become magma, they're no longer metamorphic. So this Metamorphic Lab, pretty straightforward. So again, on Canvas, you'll have choices, and I think we should have certainly the answers to most of these just based off the parent rocks. So if you look at the charts, and if you look at the parent rocks, you will find pretty much the answer is straightforward. So that ends Metamorphic Lab, where we basically have 2 textures to look at. A much smaller sample of rocks, much more easy to identify. So you go into Canvas, again, there'll be multiple choice options for you to click. And I don't see too many people getting anything below 100% on this particular lab. Start studying. We're going to have next a practice test. This will be for extra credit. So I'm going to line up in all these tables in this room. I'm going to line up one table just of minerals. Another table is going to contain all igneous rocks. Another table is going to contain all the sedimentary rocks. And then we'll have a table with all the metamorphic rocks. So they'll be all lined up here. I'll take you around the room. We'll go and do all 40 samples. So first we'll have a practice test. And that'll be for extra credit. And I will let you see the answers. I will let you see the correct answers. And that'll give you a good practice for the rock and mineral midterm exam. So hopefully we'll be able to teach in this classroom again. And I'll see you guys later.